This video is the first part of the Function I section of the Functions module. Now in the Function I section we're looking at inverse of functions. The inverse of a function results from swapping the dependent and independent variables. Note remembering that the dependent variable is the y or the fx and the independent variables the x. Now to perform such a manipulation it's often easier to use y rather than fx for the dependent variable. And the inverse of a function fx is written as f to the negative 1 of x. For a function defined as a list of ordered pairs, the inverse of the function is a set of ordered pairs with the x-coordinate values and the y-coordinate values exchanged. So for example, here I have a function f is made up of coordinates 1, 2, 3, 5, negative 1, 3, negative 2, 2. So the inverse of this function is simply 2, 1, 5, 3, 3, negative 1 and 2, negative 2. So basically the values are just swapped over. When functions are defined using a rule, so for example a formula, the inverse of the function is found by solving the associated equation for the independent variable. For ease of algebraic manipulation, it's often convenient to use y in place of fx yet again. A procedure for determining the inverse of a function can be summarised in the following steps. Firstly, write the function of y in place of fx. For the inverse of the function, switch the x and y variables, solve for y and replace the y with the f to the negative 1 of x. So let's look at some examples here. I have f of x equals x over 2. So my first step will be let y equals x over 2 and then we swap the x and the y values. Okay, so I get x equals y over 2. We still need to get y on its own, so we need to get rid of this divide by 2, so we multiply both sides by 2 and we get 2x equals y. We then go back to our inverse notation, so therefore f to the negative 1 x equals 2x. Okay, let's look at the next one here. G of x equals 3x plus 1. So we'll let y equal 3x plus 1. Swap my x and y values. Try and get y on its own. So we're going to take 1 from both sides. And now we're going to get rid of that 3 by dividing by 3. And then we go back to our notation equals x minus 1 over 3. Remember to pause the video and try some of these yourself. Don't just blindly follow. Give it a go. Okay, so here let y equal x squared minus 4. So now I swap the values, so I get x equals y squared minus 4. Add 4 to both sides, x plus 4 equals y squared. Now I need to square root both sides. Now this is y squared, so I have to do the plus or minus x plus 4 equals y. Reason being, remember, negative x or squared is x squared, and x squared is x squared. So the positive and negative give the same answer. Go back to my function notation and I just realised something. There should be h to the negative 1 x equals plus or minus the square root of x plus 4, and the one up here should have been a g. So that's g to the negative 1x equals x minus 1 all over 3. Okay, now let's looking at the next one. It's a j of x. So let y equal log 2 of 3x. Change the x and y over. We need to change to exponential form, so x to the power, base is 2. 2 to the power of x equals 3y. To get y on its own we need to divide both sides by 3, so 2 to the power of x over 3 equals y. Change back to function notation, j to the negative 1 x equals 2 to the x over 3. Okay, now note the inverse of a function may not be a function. Now what do I mean by that? Well, here's my function. Now if I write the inverse of that, so I'm just swapping my coordinates around. Now if you look at that, every x value is exactly the same here, but they each have different y values. So that's not a function. Okay, and we just did this one in the previous example, and we got h to the negative 1x is plus or minus the square root of x plus 4. Again, that's not a function because we have this plus or minus here. So every x value is actually creating two dependent variables. Each independent variable is creating two dependent variables, the plus and the minus of it. So that's not a function either. Okay, what now? We'll move on to function I part 2.